I'm gonna read out for you um, from Wikipedia the definition of religion. So I'm just reading now. Religion is any cultural system of designated behavior or practices, worldviews, texts, sanctified places, ethics, or organizations that relate humanity to whether or not we should use open source or proprietary tools. Wikipedia. No kidding. I'm going to start off with a few quotes. Let me see if I get this working. We all know this guy, right? On his wall in his office, he had this sign, this quote: "Not everything that can be counted counts, and not everything that counts can be counted." Already back then, in the 40s and 50s, he was clever enough to foresee the situation that we're having now. We have so much information, it's hard for us to actually understand what a piece of that information is going to be crucial for us, that could be lucrative, and what is not. And also there's structured stuff out there, and there's unstructured stuff. And this leads us to a kind of a dilemma. There's too much information to take in a hand. And we have another clever guy, Professor Naisbitt. He's saying basically the same thing, that now we have an economy that's based on a key resource, which is the information, that's not only renewable, but self-generating. Running out of it is not going to be an issue, but we might drown in it. So he's basically saying the same thing. And the reason that what these two guys are saying, all this information, is actually the reason that we are right here just now. So we have another great thinker who says that if data is the new oil, well, anyway, data scientists still will do it with models. And that is myself. I'm Robert. I'm the chief analyst of Houston Analytics. I've been working with advanced effort analytics, if you will, since the mid of the 90s when I took my degree in statistics. I have a history working on the vendor side with a couple of the big guys. I've actually been working out in the real life, where most of you guys are working with practical problems. Working for IBM, which I did, I could use the term data quality is never an issue. In the real life, you rarely say that one. So I've been working with that. I'm working for a company called Houston Analytics. I'm not going to bore you with a lot of details on that, but we are an analytical house, and what we want to do is that everybody out there on the market should think, all right, we have a data science advanced analytical problem. Let's hear what the Houstonian guys, what they're thinking about this. Right, so here's what I'm going to talk about. The topic of the presentation is done. We're going to talk about open source and proprietary or commercial tools, if you will. I'm going to give you a bit of my views, to say the a priori on that. I'm going to give you a bit of the trends that we're facing. And then I'm going to do a totally arbitrary, Robert opinionated thinking around the two sides. And then I'm going to summarize this. I hope that this is going to be an interactive session. So I'm going to be a bit provocative. I am going to be talking about things that I think, and I'm sure that 90% of you is probably going to think, right, he's just full of it, because I think the quite opposite of what he's saying. So don't be afraid to air those thinking. Right, my view. And here is just, I know I'm preaching for the choir now, but just to give you a view of where we're coming from. I'm struggling with a recovering cold, so bear with me. Statistical analysis has been around for, well, probably 800 years as a science. We've been, doing hypothesis testing and sample inference testing and stuff like that. It's been always been doing that. So if a researcher think that the researcher says, I think that if you smoke, you tend to have a greater risk of running into this very strange diagnosis. The data mining side of it is say, right, here's the event, the diagnosis. Now let me find out what's the anatomy of the data that is actually going to feed into giving me the higher risk of getting this diagnosis. Right, might be smoking habits, or it might be behavioral, or the DNA or whatever. So we're getting a bigger approach to it. That's one of the differences. In traditional statistical analysis, we can ask 1,200 people. We make a sample, right? 1,200. If the election was today, how would you cast your vote? And then you'd say, oh, well, I'm voting for Obama, or I'm not, you know. It's actually about 1,200 people that would, so it doesn't matter if it's the presidential election in the States or a local selection in South Italy or whatever. In the whole world, they do it like that, except for, I think that maybe North Korea, they have different ways to go about it, but the rest of us, that's the way we do it. In data mining, we don't appreciate samples. We just want the whole. You know, we want it all. We want everything. We want all the columns, all the rows, and we want to be able to make well underbuilt decisions on that. So that's where I'm coming in, and let's talk about the concept of data mining. So that I've been working in this. Sure. That's true, but some years back I made a project with one of the bigger truck producers or lorry producers here in Sweden, and the traditional way would say that, all right, let's pick out 1,500 of the lorries and make analysis of that and kind of extrapolate that to the whole fleet, which is then the first approach. But I said that, no, I don't want that. I want all the lorries to be able to understand what actually drives the vehicle off road. And next year, or next week, or next day, next hour, there's going to be a new set of trucks. And I'd kind of adapt the whole population insight to the forthcoming data. So that's my take on that. But for sure, it's not ever going to be all the people. You know, if you have an election, which by default is a total take of the population, it is never going to be, because there's still going to be some people that don't even go to the polls, right? Nevertheless, we're talking about data mining. That's what we called it in the 90s, right? And then I'm not sure I'm going to get this right in the chronological order, but we've been talking about big data analytics. We're talking about AI. You know, machine learning today is a very concept. You can't have an event like this without including machine learning. Predictive analytics, many words, but what it all comes down to, in my opinion, is that we're all talking about how could I deploy some clever algorithms to be able to understand the event that's going to happen over here. And then if the data is big, or if it's flying, or whatever, it's actually just commodities that change the situation. In essence, it all remains the same. Right. So that's the kind of the historical thinking. Statistical analysis has been around for hundreds of years. Data mining as a discipline, data science would call it today. I don't know, maybe 20 years or so. It's quite recent. When I was in school, we were working with Minitab. So this is how I learned my statistical degree, how I got it. A lot of coding, you know, it looked like, just like that, and we got a result and you know, some kind of significance value, and we worked out of that. So that was back then. But then in the mid of the 90s, there was a certain amount of evolution. So for instance, SAS Enterprise Miner came about, that's the top one. And this one, to be honest, this is a screenshot of the uplift modeling that I did when I worked for a telco operator. So here we do not only understand which customers are at risk of churning, we also understand which one have the higher savability score. Quite cool things. And you know, so this is the early shot of Enterprise Miner and the early shot of SPSS modeler. And you see that, you know, so this is actually this. We're kind of getting it this easy. I mean, there are modern versions of that. That was not the right. There you go. There are model versions of that. So these are what they look today, but they're basically the same. So they apply the mathematics in a clever way with graphical user interfaces. And now, here's where I want to challenge evolution, because now this is happening. Right? So we're going back to R and Python, and what we're doing is we're investing a lot of time and effort to basically create these codes that do this. And why is that? And here's the kind of the essence of whatever I'm going to talk about. It comes down to, as I understand it, and coming back to religion, a few of you might be Talibans when it comes to, I'm a bit provocative, aren't I? Talibans when it comes to maintaining their thoughts of degrees of freedom. Kind of look at these over here. You have these a lot of high degree of freedom. The tools are very, very versatile. You can literally do whatever you want to. You know, if you have MATLAB, there are no limitations because MATLAB can do the math. And then you have tools over here that might be, you know, you push in data at one end, and through the sausage factory, and there comes the customers that are higher churning. What happened there in between? Oh, not really that easy to find out. So, and then we have a couple of tools in the middle. They have the IBM, the SAS stack, RapidMiner would be there. But in all essence, this is the situation, and this I think, correct me if I'm wrong, this is where I think that the religious part comes in, because you're probably thinking that I, as a data scientist, I want to be in command, I want to be in charge of things, I want to be over here. I would never accept that, and I agree with that. I see that, but I think that there might be some other modus operandi that should be applied, some other thinking. Let me elaborate on that. Sure, we need to look at the trends briefly. I'm not sure how many of you guys follow the Rexer Analytics Data Science Survey. It was, you know, that giving the change of time, it was previously called the Data Miner Survey, but now it's the Data Science Survey. Here we can see this. The last report available is the one from 2015, because the 2017 is actually to be published, you know, within a week from now. So they wouldn't give me that. But in 2015, you have the R. Using R and R as a primary tool has gone, you know, quite a nice curve upwards. And in all honesty, I'm not publishing it, but if you look at the usage of these other tools that I kind of promote, they have a similar curve, but contrasting. So this is what we're facing, and this is what I'm thinking, that I really need to get my shit around this, because I'm going to be a dinosaur talking about how clever it is to be able to do things in an intuitive, easy way, when I know that the world is going to be fighting against me. I see that. I'm not stupid. But I'm good with that. Bear with me, I've thought about this. Let's compare these two. And mind you, I'm making a distinction between open source / code intensive, because there might be some proprietary stuff over here. And I'm also saying proprietary and graphical user interface, because there actually might be one or two open source tools here, right? Veka is one of them. So it's not, so to say, black and white when it comes to open source and proprietary, but it's in a general notion. And I'm also only taking into account the analytical tool. I'm not taking into account the total solution with, you know, Hadoop, Spark. I'm just looking into the stuff where we actually generate the coding, the analytics, if you will. Wow, let's see, let's go. Bear with me. Please oppose to me whenever you think it's appropriate. Innovation and development. So, innovation development, how dynamic are the tools? If, you know, the world is changing, there's new algorithms being developed every day, how dynamic are they? Are they actually applying it or not? And my take on this is this. So, the open source, the code intensive stuff, gets actually 5 Houston Analytics out of 5 possible. Good on ya. I'm taking that from, you know, if there's a researcher, statistician, or data scientist in China developing a new algorithm, you know, it will be published within 6 months later or so. It's going to take the giant IBM 10 years, maybe 8 if they're quick, to get the same stuff. You know, the random forest is a perfect example of that. They took a number of years to get it in there, but they actually early on had an R version deployed into their tools within 2 or 3 years, which was kind of rapid to be in that world. Yeah, sure. That's a good point. And I think that's a good point. I haven't even thought about that. But let's assume that if the Chinese researcher, the PhD doctorate or whatever, let's assume that he has gotten his stuff approved by his peers. Then I'd say, because IBM or SAS or whatever of the giants, they would never publish anything that's been tested, and triple tested mathematically. And I'm assuming that these researchers would do the same. Right, so let's carry on. There's quite a few of them. Learning threshold. You know, we've been talking a lot about hiring teams of data scientists. IBM had this really interesting presentation about data science competence centers yesterday, which is pretty cool, because the large part of you guys already know that, so you can do the R, the Python, or whatever. But let's say that we just take an ordinary guy from the university with a relevant education, but has no experience in working with this. I am going to insist that saying that the learning threshold for the open source, the code intensive, is severely higher than for these graphical user interfaces. Right, so there's an obstacle to get started. Once you're started, you're good, but to get there, might be, we have to work on it. Collaboration. So when your data science center of competency is all set, and it's because you're working in a global organization, people are working with different type of models, different code snippets, different artifacts all over the world maybe. It might be a challenge to do this in a open source environment. Oh, that's not the right one. There you go. But so I'm giving the code intensive solutions 2 Houston Analytics out of 5, but I'm getting the proprietary ones 4, because these guys actually do have solutions for that. There probably are similar stuff in both R and Python, and there are other stuff around that could be used, but I'd say that there's a slight advantage to the GUI world, at least there. Maintenance and governance. How about that? So if you're a company, like I will imagine that what Casco is struggling with, if you're having 1 or maybe 5 or 15 models like the one we just heard about, that's fair enough. It's we can maintenance those. We govern them. We can make sure that they're actually delivering what they're supposed to deliver. But when that number comes up to 800, 5,000 different models, this is going to be a bitch, to be honest. The GUI world does have solutions for that, and the maintenance and governance is something that they're going to be struggling with. It's going to be undocumented artifacts and a lot of code that you really need to understand. Are they delivering as they expect to be? Well, one more important one. How about that? Deployment and automation. Because once we've done this very clever model to resolve the recipe recommendation in Kesko customers in Finland, we want to make sure that it kind of happens, so the report is there every Monday morning for the management team. The extra recommendations is thrown back to the data warehouses, where it can be actionable at literally real time. So I'm again going to give the lead to the proprietary ones, because there are a lot of solutions that actually deal with this. Versatility. Coming back almost to the first one, and also to the slide where I talked about degrees of freedom. Yeah, you know it, the winner here is for sure the open source ones. Because if you know your coding, there are no limits. And if you're using SPSS or SAS Enterprise Miner or whatever, there will be limitations to you. Right, I would like to do that special linkage function within my logistic regression. Nah, there's no button for it, so you can't do it. But in open source, no worries. You know the function, you can use it. Yeah, I give the win to the open source. Scalability. And here's I'm going to click it all the way. If you look at young companies, you see my young, like Klarna or Spotify. I'm not sure if any of the people here are from Klarna or Spotify. But you see that when a company matures, and this is where you guys in Kesko are going to end up, where you are now, you're kind of starting this featuring, you're quite good. But once this gets out of volume, with volume in data and volume in number of functions and volume in number of data scientists that are working with this, it will become a problem. Again, proprietary does have an edge here. They have, so to say, a strategic and tactical approach for this. Direct cost, yeah. Easy to say. There's a hefty price tag connected to IBM or SAS Institute products. Oh, Jesus. And it is not as hefty when it comes to the code-intensive world. Even though, mind you, we know that it's never going to be free out of the box, because there's always need to be these support deals or whatever. But it's pretty, well, quite a lot less. But then we have the indirect costs, and here I'm kind of putting the indirect costs together with as a function of the TCO, total cost of ownership. And here I say that even though the initial cost is low, there will be a total cost of ownership that will not be as low as it appears, because you need the graded teams. You're going to spend a lot of money and time for getting the other ones resolved, the collaboration, maintenance, and deployment. So at the end of the day, there's been a few studies that actually claim that the total cost of ownership will be higher for an open source approach than for a commercial approach. Speed. Here, I mean speed as in speed for develop a model. If me, being an SPSS modeler aficionado, would be challenged by any of you to do an analysis compared to R, I think it's going to be quite hard to beat me in actually doing the job. You have to be freaking quick in R coding to be able to beat me, because I have these, and then it just happens. But nevertheless, I know for a fact that the people that are pretty quick in coding, they can do stuff really, really quick. So that's all right. But still, I'm giving it a win here to the proprietary guys. And then we have the last one, the resources. Also, again, a topic that has been discussed a lot. There's a lot of more resources out there. So if you need to hire a data scientist, it will be easier to say that we need a guy that knows his way around R or Python than to say that we need a modeler jockey. Again, if you look at it, if you take this is also quite interesting. If you take a data scientist, let's call the guy a data scientist. He's going to cost you like 45,000 kroner a month for 3 years of experience. That's a good salary. They're making good money. If we call the guy instead, and of course connected to the R and Python, if we here say, we need a statistician that has 3 years worth of experience from SAS Enterprise Miner or SPSS Modeler, it's going to be like 30,000. So the data science tag is actually what is paying your vacations. Good on you. The statisticians, not so much. So, well, that's an interesting one. I think that if we look at this 2 year forward, the one is still going to be there, but here it's going to be like 4 or 5. So the resources for the open source is going to be increasingly higher, and it can't get lower than 1. Anyway, summing this up, the overall win, from my perspective, is the commercial graphical user interface environments. I would be able to be glad to take a debate on those, because I see that we are now running out of time. But after this, I'm going to be in one of these rooms over here, and I'm up for the talk for this. I'm going to make a summary, a brief one. That what you guys need, because I know. This is where we're going. I've seen the stats. We're actually getting an increasing usage of these code-intensive solutions. So I know I can't fight gravity. But guys, what you need to do is to be able to add on functionality around this that makes the tooling intuitive, collaborative, designed for governance and scaling, right? So there's when I was working for IBM, I had this, the SPSS portfolio was my baby. That's what I did. Within the SPSS, you could actually incorporate R code, native Python code, and get all the benefits from the, you saw them just now, from the open source world, and use it as analytical assets within SPSS. That means that every pros that I push for the graphical user face will be also on the open source. Well, you might not want to go there, but then there's still tools that are proprietary, that are commercial. SAS have their VIA, IBM have their DSX. I think there's going to be a DSX demo about somewhere. That actually kind of kills out a few of these downsides of the open source world and kind of makes them right, if you will.